Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No engines, no libraries, it's all us. And we are actually at the point where we have just wrapped up doing our normal map code, which was kind of cool. We still have some stuff we want to do with lighting. We finished the normal map stuff to a large extent, but we have some stuff we want to do with lighting there. What we kind of decided when we were in the middle of that was that it was really getting to the point where we had to sort of lock down all of our coordinate system stuff in the renderer because we'd never really done that, and it was kind of getting to the point where it was getting kind of silly because it was really ad hoc. And so what we wanted to do this week, before finishing up the lighting, which is going to involve us sort of playing around with a mapping, like some kind of a mapping to get localized light sources. We have our sort of sky and ground stuff working relatively well right now, but we don't have sort of local around you sort of light stuff working. What we wanted to do before we went and did that was we just kind of wanted to take a little bit and go through the renderer as it stands and sort of lock down, okay, what's the coordinate system, who's in charge of doing what when, what is the format for the bitmap at the end of the day, is it bottom up, top down, all these sorts of things. And so it's not glamorous work certainly, but it's the kind of work that you want to do periodically because you don't really want to let things kind of get into this state where everything is sort of Rube Goldberg-y, relying on hidden knowledge about who flips what when, and there's ends up being 12 negatives, and then you add the 13th one so that it can actually flip, and they're all canceling each other out, and all these sorts of things. You don't want to get into those situations, so periodically when you kind of get that feeling that it's a good time to sort of start to solidify some rules, you kind of want to take the time to go through and do it. So that's what I'd like to do this week. I don't know that it's going to take a week, obviously, but what I'd like to do is start the week with that, and just so we have plenty of time if we need it, to go through and just clean out all of that stuff and, sort of have a really good idea of exactly what the coordinate system is at all times. And there's some nuance to that as well, which is that Z is kind of up in the air at this time as well, and so I feel like what we kind of want to do in that process as well is get our Z handling straightened out as well, because there was a bunch of things about like when things get displaced off of the ground, because since we're in pseudo 3D, we kind of have to have little weird things that we do, like moving things up off the, moving things up in Y, even though technically they would only like be coming out of the screen. It's all sorts of things like that. So when we do this pass, I'm also going to be trying to get that stuff corralled a little bit more, because one of the big reasons that we decided to do the renderer at this time in the first place was because we really wanted to get our Z handling nailed down, right? And so we kind of have to remember to keep an eye on that at the end of this process, when the renderer that we're doing is done, we want to have that good Z handling in here. And so through that entire process, we kind of have to keep looking at Z and going, how do we want to handle this? What are the different rules that we're going to use? What are the different things we're going to support? And so that's the other thing, that when we go through this process to sort of clean up our screen transform stuff, now would also be a good time for us to think about how that Z needs to get cleaned up. So today is day 104. So if you have pre-ordered the game on handmadehero.org and you have the latest source zip, go ahead and unpack day 103's out of sources out of there. That's where I'm going to be today, and so you'll be right on target. You'll be right where I am. So if you remember where we left off last week when we finished everything, in terms of the normal mapping, we sort of finished off just having the sky and the ground reflected, and we were pretty happy with where we ended up with that. But of course, we still have, you notice the middle of our sphere is not reflecting anything. That's the green map here, which we have not done anything with yet. And so while we have sort of a notion of how the sky and the ground is reflecting, we haven't done sort of the near field reflection stuff. And so we're going to just postpone. We're going to leave that here where it is, because we're relatively confident that we're doing the basic reflection stuff correctly. Although you'll notice the ground, one of the motivations for going through and doing the coordinate system fix is because right now we actually don't have the ground and the sky in the right places, right? The sky was the blue one and the ground was the red one. And that's part of that whole Y flip coordinate thing. So there's a couple of things like that we want to take a little bit closer look at, and then of course we want to start working on our near field lighting, the middle of the reflection here. And we also have some stuff we want to do with glossiness and other sorts of things like this. So we're just going to put that on hold for a second, remember it all, and we're going to then just pop over to doing the coordinate system pass and see if we can't nail the coordinate system pass down, then pop back over, sort of return to the normal map stuff, at which point we know that we've straightened out all of our coordinate system things we want, so we can make sure that all of the normal map stuff now is absolutely working in the correct coordinate spaces. Because that's one thing that we, again, don't really want to do. We don't want to go in here, for example, and fix this so that it's reflecting the sky in the top and this in the bottom, when we already know that the coordinate system stuff is not really being handled correctly through the pipeline. Because at that point, what we're doing is we're just adding a bug on top of a bug. We're sort of adding, adding that second negative to reverse a value that shouldn't have been negative in the first place, right? And so you really just don't want to do that. You want to make sure that you have the minimal number of corrections in a pipeline as possible. You want corrections to actually be correcting for something real. You don't want them to be correcting for things that were done improperly up in the pipeline, because later on, if you then go to correct the things in the pipeline, you will break the stuff later on that was depending on those bugs, right? And so that's, again, just to reinforce it, that's the reason why from this point here where we're at, I feel like it's a good time for us to address those other issues. So there we go. That's basically what we're looking at. So let's just start. We have sort of a lot of looking to do here, so let's just go ahead and start defining things. So we have our handmade render group, right, which is what we're sort of using at the moment to build out our renderer. And the way this is working is we have our push buffers, and the push buffer is the thing that we put all of the render elements onto. Like everything that needs to get rendered gets an entry into this push buffer, and then it goes out to the renderer, and the renderer just does whatever it needs to do to make that happen, right? To sort of go through all those commands and make them occur. And so right now we don't really have that many different types of things we push on there, but what we can already see even from the basics, and we can discount the coordinate system at the moment, right? So this one's our test one, right? This guy right here, this is only for test. This guy is the thing we were using to do our normal mapping and stuff like that. So we don't really necessarily care about him too much, but what we want to do is start to look over these guys here. And maybe what I'd like to do is go ahead and switch back to rendering the game that we had it as we had it before we were doing the normal mapping tests, and sort of work from there to figure out how we want to start rearranging stuff that gets submitted to the renderer to make sure that everything is okay. And so this is the code right here that we were using. And so I'm just going to go to draw the normal map stuff. I'm just going to go ahead and get rid of that for the moment, right? I'm just going to go ahead and get rid of that entirely. And so if we run the game now, we should see that we don't actually render, we don't do any of this mapping stuff, we don't draw any of this coordinate system stuff. None of that should be happening. As you can see, we just have a much more straightforward situation. Okay. And then we have to kind of come up here and get us back to a situation where we are actually drawing everything in the game. Now, if I remember correctly, we actually also had a thing where, I'm trying to remember how we ended up commenting this stuff out. So we had our standard room stuff. Like, it's been so long we were working on the renderer, I don't even remember what stuff is turned on and turned off with the way that we were doing things in here. But anyway, so it looks like we're still constructing our world properly, I believe. It looks like that's just initializing like ground chunks and all those sorts of things. We turned off generating our ground buffers. I suppose I could turn those back on for the moment. Let's go ahead and do that just to make sure those are still working. Although it doesn't appear like they are. Although I guess that's only on executable reload, so presumably that's just the thing. All that actually does is force them to regen, so I suppose I don't actually need to turn that on. And so we come through here. Here's our, our adjustment code for actual controls. Here is our world chunk rendering, which still looks like it's active. So it looks like we still actually built everything, so I'm guessing that really, I thought we'd turned off a bunch of stuff, but I guess we didn't. I guess all we did was just inside the render group, did we just turn off the render calls? I guess that's all we did. It looks like we just turned off the bitmaps. So I guess we really don't have to do much to get back to the state that we were in. If I'm not mistaken about that, it looks like this is it. Just turn that back on, and there we go. Looks like I also have to update that for the fact that we changed it to have a color, an actual color value there. So yeah, okay. If I run this now, it looks like we've got our whole world back. So I guess there really, I thought we had turned stuff off. We hadn't. So we're back to exactly our game state that we wanted to be back to. So now we can just go ahead and start trying to make sure that the render is doing everything that we want to do. I'd like to turn off so that we can see the edges between those ground patches. Excuse me. I'd like to be able to see the edges between those ground patches, and in order to do that, I'm going to have to turn off those yellow lines. And the reason that I want to do that is because we're going to be playing a little bit, again, with scaling things up and down now. And because of that, I'm a little bit concerned that if I have those lines on, I won't be able to see seams or edge problems between the world tiles. So I want to turn off those yellow lines that we're using for debug because they're going to be counterproductive at the moment. Even though they are handy so we can kind of see where our ground tiles are, at some point they're actually going to obscure potential bugs, and so I want to remove those. So let me go ahead and turn that off. I believe it's just this guy right here, 0. And so that'll get rid of those lines. And we can even see actually right now there actually are seams between these guys that we weren't seeing, right? And so somewhere along the line when we had those on, probably because of our Y flip again, right? Because you can actually see these kind of look, let me double check here. Yeah, these kind of look exactly like they're out of order. So you can see that little splat right there looks like it's probably the bottom of that thing, right? So these are kind of going in the wrong order as well. So yeah, again, just wanted to turn those off so we can see it because we're going to be trying to get all this coordinate stuff nailed down. We certainly don't want things that are going to obscure obvious bugs like that was doing. All right. So first thing we're going to do is we're going to sort of define a couple things up here. So we're going to talk about what the renderer has sort of how the renderer is working here. So we're going to say a couple things because based on what we've done so far, we kind of know what they are. So everywhere outside the renderer, Y always goes upward, right? So it's always X to the right and Y upward. And I feel like there's really hasn't been any problems with that so far. Our only problems with that is where we have allowed sort of Y up versus Y down stuff to leak, in and out. So we want to go through and make sure that that's always true. The other thing we want to do is, I think at this point we might as well switch to a bottom-up bitmap because we actually did work to give ourselves a top-down bitmap, but now, since we're doing everything in that bottom-up fashion, it seems like we probably just want to switch to being bottom-up everywhere, right? And so all bitmaps, including the render target, are assumed to be bottom-up, meaning that the first row pointer points to the bottommost row when viewed on screen, right? And so there's a couple things that we have to do to make that happen. One is we'll have to go back into the platform layer and change a little bit about that potentially. And another one is when we're doing our bitmap loading, we may have to do a little bit of changing there. So we'll do that. Finally, I guess probably what we would want to say is, well, I think that may be it for now. I was going to say we might want to talk a little bit about what things are specified. I guess what we could say is, I guess everything, like unless otherwise specified, all inputs to the renderer are in world coordinates, which are meters, not pixels. And so we'll you know, anything that is in pixel values will be explicitly marked as such. So the assumption can always be basically that everything is going to be in meters unless otherwise marked. And I think that's probably a pretty good idea. Finally, as far as the Z stuff is concerned, I think there's maybe one more thing I want to say, which is that at this point, now that we've sort of gone through enough things, I think I'm kind of comfortable saying I think the world should just be broken up into discrete Z slices. It really feels like that's just the way it's going based on everything that we've done. And, you know, when we're talking about having sort of the reflection mapping as well and the different layers, it feels like we just want to put our foot down and say, we're not going to get any benefit out of having anything other than discrete Z slices. There can be holes in the slices potentially, but I think we want to say that there are. And so, you know, I guess I just want to say something like the world is, sorry, I should say Z is a special coordinate because it is broken up into discrete slices, and the renderer actually understands these slices potentially, meaning that we're not going to force the renderer to be Z agnostic. The renderer can, if it wants to, think about the fact that there are Z slices for sorting purposes and all these other sorts of things. Because it seems like that's going to be the way that things want to go. Just based on everything we've done so far, it feels like it's going to be hard to make the code work properly if Z is arbitrary, because there's so many things due to the 2D nature of how things are working that really want to know about sort of these chunked aspects of the sort of depth part of the world. I think that's pretty good. I'm going to go ahead and start with the easiest one today, which is just that the render targets are going to be assumed to be bottom up. I think we can get that done relatively easily, and so I'm going to make that be today's task. So let's go ahead and take a look, reach back into your memories for when we were working on this code way back at the beginning, and we had our resize div section, and the resize div section code, of course, did this sort of allocation where it was grabbing, using virtual alloc, it was grabbing a chunk of memory, and that is what we were using for our display buffer, correct? And so I believe that what we were doing per the Windows specification is, if you take a look at this specification that we were giving to Windows here, this is the actual spec. We pass it, this buffer info thing. You can see that it gets passed when we actually display the buffer. This buffer info is the thing that tells Windows how to interpret the memory that we allocated so that it can blit it to the screen. And one thing that you'll notice is there is a negative on the height. And that is Windows convention for saying that something is top down. Windows by default, because of the OS2 days, long story not worth getting into, they started using bottom up as their convention for how things were stored. And some things still wanted to be top down, so they introduced a convention of a negative height means that the height is going to be interpreted top down, right? So it's almost like a flag. They just used that high bit to say so. So all we really have to do, I think, at the platform side of things, right, is negate that, right? So if we go ahead and negate that, then when we actually run this, we should have, at least I would think, I guess I lied. I feel like that should have flipped us around, did it not? Buffer info, buffer height, and stretch GI bits actually does buffer info. They both use buffer info. So I feel like that should have done it. That's kind of unusual, to say the least. But that definitely did not flip us upside down. I mean, our guy is there. Oh, all right. I guess I just did not restart. I was like, that should have done it. So there we are. We're upside down now, right? And that's exactly what we want, because now at least we know that we're drawing that our first row is kind of that bottom row. And so now what we want to do is we want to go into the renderer and start to work out how to make sure that it's now going to render us flipped the right way given this. Okay, so that's pretty straightforward. So we come in here to our render group, and let's go ahead and take a look in here. And we got quite a bit of stuff that comes through here that works with coordinates, and you can see a lot of things where we use these negative offsets. So really, there's not much we can do about this other than kind of going through and taking a look at things one by one. Again, this is sort of why I'm saying now is a good time to do this, because we've written a bunch of exploratory code, but we're starting to write real code now. Like, especially when we go to start optimizing things, that's going to be code that we're going to want to keep. And once you start getting a lot of code in there that you want to keep, it becomes difficult to go in and make subtle changes like this. And you end up having to look at a lot of code and see what it's doing. And so that's, again, kind of the reason why I want to do this now. I want to make sure that basically we're sort of set with a good coordinate system from here on out, so that we will never have to worry about fussing with that again. So all of these things, let's see, bilinear sample, that's, these are using y's that are going upwards, it looks like. Again, we've got kind of that convention in here for all of the new stuff that we wrote. It looks like we wrote it so that our y's were generally going upwards, and so that's a good thing. Sampling of the environment map, again, that looks like that's going upwards as well, and so on. Let's take a look at this here. We've got the x-axis, y-axis stuff. That's coming through with the origin properly, and so on. That all looks good. Yeah, this all looks good. Nothing really unusual here. Now you can see this is also, it's pre-stepping, and it's pre-stepping properly, so this is not adding in any kind of displacement. So that's also correct, not going y up. So this all looks pretty good, I feel like, for the most part. That looks like that is kind of working the way that we expect it to. So I'm going to leave that be for now. That looks fine. That all looks pretty good. And let's go ahead and check draw bitmap. Draw bitmap is so you can see here that, again, it's using that same pre-stepping pattern. So there's that does not look like it's trying to accommodate for any sort of offset stuff there, so that's good. This all looks like it's working properly. So it looks like the draw bitmap code is also working properly y up, so it's really just the inputs to it. It looked like that would be wrong for the most part, I believe. So let's see here, we've got our saturation change code, which someone asked me to add. That's just kind of sitting there. That obviously is operating on all the pixels, so it really doesn't care. So here we are in some draw rectangle code. This draw rectangle code looks like it's treating the y's and the x's relatively straightforwardly, and again, it's because drawing an outline, it wouldn't really care, again, which direction the y was going per se, so I think that's probably fine. We've got our mat, and that looks good as well. Again, no apparent pre-step problems there, so this all looks good. So it looks like most of our code looks like it's pretty sane, nothing particularly weird going on there, but okay, so now we're starting to get into stuff that's got it baked in. So you can see this is now handling these two things asymmetrically, right? We are sort of having all of our points come in with y going the wrong direction, right? So you can see there's that negative in there. And one interesting thing about this is it looks like if I wanted to, I could do entity ground point here as a v2 and take that screen center, right? And just do screen center plus that, right? Plus the entity base p xy, right? Because this is the exact same equation in both cases, right? Nothing particularly weird going on there. And that means we can also do essentially probably that same thing where if this is the equation for the center, it's the entity ground point x and then the entity basis offset. So we could also similarly, ground point, entity ground point. We could similarly just take these guys together like so, and then just add in this z offset here, right, like that. Yeah, so that looks all pretty reasonable. I don't see anything strange there. Now this is, I feel like this is something that this has sort of that z-ness in it. So I'm going to go ahead and put a to-do here. We're going to introduce a to-do term, I think, that we can search for later, which is like, you know, z handling is going to be our term. This is our to-do. And I'm just going to put that in here. In fact, I'll just make a little cut and paster that I can use here. And so as we go through this, when I see things where we've got that z handling baked in, I'm just going to tag them. And that way we can go through on a second pass. So after we finish getting the top-down stuff going and we want to start working on the z and how we handle that, we don't have to go through and look again because we'll already know kind of where it is. All right. So let's take a look here. Now we've got the render group to output call. The render group to output call is just what interprets everything in our push buffer. It looks to me here like we don't have anything particularly weird going on in here. These are just kind of passing through for the most part and calling utility functions. They are not really interpreting the y at all. This guy is, again, our test code, so we don't really have to care too much about that. We'll revisit that again in a little bit. Our allocator, obviously nothing weird going on there. Our push render element is just a thing for creating stuff on the push buffer. So here we go down to push piece. Push piece, again, doing that negation, so we want to get rid of that negation, certainly. Now the alignment, is interesting because I would like to also know where that alignment is coming in. The alignment would have to have the y, would have to have some opinion of how the y is supposed to work as well, and so we should probably go take a look at how we are computing those alignment values when we load the bitmap, right? Because if I remember correctly, we kind of have a thing in here where we sort of load our bitmaps and make those alignments like so. You can see these alignments are actually done, they're kind of baked with the top-downness in them, right? This is a top-down value, and that's technically wrong. So I don't know exactly how we want to fix that. I would say that we probably want to fix that right here at the head end. So I think what I might do is say all of these alignment values should actually be correct coming in. So I'm going to do set top down align or something like this. I'm going to go ahead and introduce a function that we can use so that we can keep the data being specified the way that it was, because that may be a very intuitive way to specify that data coming from an art tool. But since we want all of our stuff to be in this particular coordinate system, which is not what GIMP was using, which is where we read these values out of, if you remember correctly. And, you know, we'll have to think kind of more about how we're going to get these at the end of the day, but at least for now, we want to make sure that we've got that handled properly. And so those alignment values, just taking a look at them, yeah, so that should pretty much handle it. So if we take a look, cape head torso, set top down align. The only problem there, well, I guess they are all hero bitmap types. So I guess this will work okay, but it's going to be a little bit more complicated function if you think about it, because since it is a thing which actually has 3 of these in it, we have to go sort of looking to see how those are going to be aligned. I guess they're always all the same size, and so I guess it doesn't really matter. So I guess the thing that I'm trying to get across here, what is happening? Am I closing down Mischief? Is Mischief just crashing or something? Mischief was closed before, remember? The other time on the stream? And I don't know who is closing it. Is it me? I'm not sure. Oops, I don't actually want to do that. I wanted to load it in the Blackboard. There we go. Yeah, I'm not sure what's going on there. But anyway, day 104. So what I wanted to say about that was just that, you know, we've got these sort of bitmaps here. There we go. We've got these bitmaps here that are like, you know, head, torso. I don't even remember what they are. Head, cape, torso. Oops. Cape, torso. We've got these bitmaps, and we were previously specifying stuff from here, like down, right? We were saying how to get there from here. And we have to flip that around so that now instead we're telling how to get it from the bottom up, right? Math style. So that this is our coordinate system. And in order to do that, in order to flip that, we need to know how high the thing is, right? Because without knowing how high the thing is, we wouldn't know actually what that difference was going to be. And so the weird thing is that that actually is going to work because all of these are always the same size at the moment. But that's kind of one of those things where each one of these should really probably have its own align eventually when we get into animation stuff more, because we probably won't want them to have to all be the same size. That's just the way they happen to be now because they're exported from the same source. So anyway, let's see. If I go ahead and make this function, set top-down align, and that's going to take the hero bitmaps. There we go, hero bitmaps. I don't even know why this is here. Why here? There we go. So then all that really needs to do is just take a look at the first one, really, and take a look at whatever that height of the first one is. And it's going to take the align, the y component of the align. And again, we just want to kind of flip that around. Now, it's a little bit delicate because, again, we actually need to make sure that we get it exactly right. And if we were to flip it like this, what would happen is, remember, the height is going to be 1 greater than the maximum y value for that bitmap, right? Because let's say that there were 50, let's say the height was 50, well, the maximum y value would actually be 49. So if y was set to 49, we want it to be on the 0th row, which means we really want this to be -1, right? We really want to talk about it. It's a little bit of a fence posting thing there, right? Not a fence post. I don't remember what you call those. Just the off by 1 kind of thing. We want to make sure that we reduce that by 1 so that when we have an alignment that's right on the edge, it becomes 0, which is what we actually wanted. So that's actually what the alignment actually has to be. So here we go. Let's pass in that align. We set the align, and now we can go ahead and record it properly, right? Like so. I think that's all we really have to do for that. I don't think there's anything else. So once that top-down align is fixed, so that's good. Let's pop back over to the render group. So now when we subtract the alignment, that'll work properly, both in X and Y. They can be handled symmetrically, no problem. They're both correct, and so that's good. But again, that's assuming that the bitmaps are also bottom up, which we haven't necessarily done yet, so we're going to have to do that as well. Let's keep going through here. We have, again, that negation on the offset Y, which we didn't want. We've got our push render element here. Everything else in here looks relatively good. It's just storing things up. Nothing particularly weird going on there. We've got our rect outlines. Again, nothing weird there. Duration, coordinate system. So all of that looks relatively good to first approximation. Let's go ahead and close this out. And so now we should get a situation where we are moving properly, which we are, and everything should be going in the correct direction, but all of our bitmaps should be upside down. And the reason that they're upside down is because we are not loading them bottom up yet. And so that's the next thing that we have to do there, which will be, I believe, pretty straightforward. Okay, so let's get started with that. Open up handmade.cpp. So when we load our bitmaps, right, we've got our bitmap debug bitmap loader here. When we load our bitmaps, you can actually kind of see we're looping through them here. You can actually kind of see that when we get to the end, we actually go through some trouble to flip them, because the BMP file format actually normally does store the things bottom up. But what we did is we pre-stepped to the end of the bitmap, right? And then set the pitch to be negative. So if we want to undo this, so we were like flipping things from the fact that they were already going bottom up. So if we want to restore what it used to look like, we can just set the pitch back to be something that steps through the rows in the order they were actually in the bitmap file, and then just not do the pre-step, right? So get rid of that, right? And so if we do that, now we should actually have things that are organized in the appropriate fashion. Now, one thing I do want to do, though, actually, now that I think about it, what I'd like to do is I'd actually like to make this look like this, and I'd like to just leave this out, like so, something like this. And the reason that I wanted to do that is just because in order to, and in fact I could do it like this as well, just flip that guy around. What I'd like to do is later on we might end up loading things that aren't in that order. In fact, I think, technically speaking, the height in the header of the bitmap, if it is negative, it's a top-down bitmap. And we just don't have any of those right now. And so what I'd like to do is sort of say, okay, assert that that result height is greater than 0, or equal to 0, I guess. And later on, we might want to support the ability to load in either direction. And so this is kind of a nice way that we can just flip things if we need to. So if the bitmap itself was actually top down, that would actually not cause a problem for us. We can just turn this case back on with an if statement or something. So I'm not going to delete it entirely. I'm going to leave it there, but we're just not going to use it at the moment. And so now we're back to, as you can kind of see, we're back to relatively good in terms of everything being sort of aligned properly. But I don't know if you can see this here. There's sort of still a bit of a weird like offsetting kind of a problem. Like I'm able to walk through the tree line above where the hole actually should be, right? So we're not, and you can see I can walk into this line. So we're still offset. Where we're drawing is still a little bit offset from where everything actually should be. And similarly, you can see if I jump, my Z is actually going in the wrong direction as well, right? I'm going down instead of up on my Z, which is obviously not what we would have wanted to have happen. Okay, but we're getting there. We're almost done. So let's go ahead and fix that Z thing first, because that was kind of a little bit funny as well. So let's take a look at why that is happening. So when we do our push piece and we push our entity Z's on there, I'm trying to remember exactly how all this stuff works, but I believe we have this negation here where we're doing the entity Z. This negation, again, this is sort of a Z handling thing, which I haven't really looked at, but this negation was designed to make sure that you go up the screen in terms of going up in Y, right? Which used to be negative, now it's positive. So I believe that really all we're seeing is the fact that was negated to make it work in the old scheme. So I suspect that was the entirety of that problem. So that's leaves us with just this one, which is that we don't quite, you can kind of see we just don't quite pick the right pace. So it's like everything is being offset up a little bit, and it'd be nice to figure out what was going on there. One possible, obviously, candidate for that is that we've done our alignment wrong, even though I tried to kind of handle that. One thing I suspect is that there might be other alignments, like for drawing the tree, that we haven't actually fixed, because again, this was all very ad hoc. It's very much test code. And so yeah, so you can kind of see here, here's our wall function. It's got an alignment that's baked in, and that alignment is going to be wrong, right? That's just an incorrect alignment. And so we want to be able to adjust, and here we go, the sword, same way, right? So we want to be able to make sure that these alignments are adjusted, and so that they're not all kinds of wrong in terms of going bottom up, in terms of being expressed in top down, but done in bottom up. And those appear to be the only ones that we've got, so that should basically handle it. So in order to do that, I guess what I'm going to do is say I'm going to do a little thing here where we'll just do alignment, and I'll do top down align, and we'll just do something that actually just returns the value for us, like so. And that way I can do that pretty easily here. Again, this is not code that I think we'll ever actually need to use because we'll actually be getting these alignments from the data itself eventually when we have more art assets and we have sort of more of I guess a stable data format that we're loading that isn't just bitmaps. But for the moment, while we have these in the code, I just want to make it easy for me to deal with. So that should make it much easier to deal with. So let me just double check to make sure we've got them all. I think there was one more here. If I remember correctly, wasn't there one more somewhere? No. No, there wasn't. So never mind. I guess we've got the sword. We've got the, well, and I guess we just never used one on the familiar. So the familiar is just flat out, oh, it uses the hero bitmaps align. Okay, so that's fine. All right, so all we really need to do now is just make sure that we have that top-down alignment function so that all of those things are aligned properly, right? And we can go ahead and put that in here. There it is, top-down align. And that just is going to do exactly what this other function was doing. Oops. Exactly what this other function was doing, only now it does it just on the vector, so that if you happen to want to have, to do it without a full hero bitmaps thing, you can. So here's the bitmap, there's the align. And so what we'll do here is say, okay, the align y, again, equals sort of that bitmaps height -1 minus the align y, and then we just return the align. It's exactly what it was. And so here we can just do top-down align, bitmap, we'll do it on the head, like we were, and we'll pass it the alignment. That's all it has to do, like so. And now, what was that? Yes. Cannot convert. Again, these all need to be pointers. There we go. And now, we may even be back to parity. Yes, we are. There we go. Lovely. And so now we no longer have any Y flipping going on. And so that's good. So we're getting closer. We're definitely getting closer. We've got the everything is bottom up, which will help us too when we do our OpenGL, or honestly, I think it's probably, I don't mean to spoil the surprise, but honestly, I think we'll probably be able to do Vulkan. I don't know. I mean, we'll see, but I'm just assuming that based on the way that the rendering stuff has gone so far, it feels like our software renderer will be fast enough to play the game, and so we will have the luxury of waiting for Vulkan or something like that. And that's really what I prefer because it's way more low level. That'll be way more low level stuff than if we were to do OpenGL. But anyway, point being, a lot of that stuff tends to be about bottom-up coordinate systems as well, and so it kind of also helps us not have too many differences between our software and our hardware pipeline, which again just eliminates frustration and confusion, so that's pretty good. All right, so next thing we should probably do here, we obviously had introduced a bug somewhere with our ground stuff is now flipped. Our grounds are in the wrong places. And so it would be probably a good idea just to quick take a look at what's going on there. I have no idea what is going on there, so we should probably take a look at that and just see if we can figure out why our grounds are wrong. I don't know when that started happening. But, so in here, we've got our ground renderer, like so. It goes ahead and loops through all of the ground buffers we have, and it pushes them using the width and the height, let's see here, is that an alignment value? Yeah, it's got the delta xy. So this is all done in y up, as you would expect it to be. I don't really see much in the way of problems here. I'm going to go ahead. So that looks about right. So our subtraction here that gives us our delta, we know that all of that is done in meters, which is good. So there's something that's a little bit odd that I don't super understand. Is our push bitmap call actually directly in pixels? Can that be true? Is that how that's happening? Let's find out. I'm really glad we're doing this coordinate system stuff because I don't like having to guess about these sorts of things. I like to lock them down and then not have to think about them anymore. So that's going to be very nice. So when it does a push bitmap call, it looks like it depends on what our actual setup was here, because it's going to call get render entity basis p, right? It's going to do this on it, which is kind of a lot of randomness. And so it is going to do stuff like meters to pixels and stuff like that. And so I'm not entirely certain what exactly that is doing. I'm guessing that must just be the alignment. It is the alignment. So that's going to be, that alignment is correct because it's always going to be, no matter whether you're going top down or bottom up, it's always going to give you the center, right? Because the center is the same whether you're flipped or not. So that shouldn't be causing us any problems. So I'm wondering if it's just in our ground chunk construction code, if we've baked in the flipped Y into there, and we should remove it. If that is the majority of the problem, I'm not entirely certain, but let's take a look. So when we come in here, we are looping through a bunch of chunks. Yep, we sure did. There it is. And that, of course, will cause the problem. So, yeah. Perfect. So I think we have now successfully gotten rid of a bunch of cruftiness, right? We've got about 8 minutes left. But we've gotten rid of a ton of the cruftiness there in terms of people negating Y and other kinds of ridiculous like that we were doing just while we were kind of testing. Again, there was nothing wrong with that. That wasn't bad what we were doing. You want to focus on whatever it is that you're focusing on. So you don't want to spend a lot of time all the time thinking about, oh, wait, I got to worry about this, I got to worry about that. You need a certain degree of concentration. So it's not bad to do stuff like just negate Y because we need to do something or whatever. You saw me do that a bunch of times, and that's actually totally fine. I wouldn't have done it on the stream if I thought it was a bad idea. The important thing to remember is always to know when to stop and correct things. And again, it's a little bit difficult because it's one of those things which requires some experience to know because it's a trade-off, right? Anytime you go and stop and correct things, you're losing momentum on whatever you're working on. You're losing the context, mental context for what you're working on. There's a bunch of costs involved to going and doing something right that needs to be done right, but there's also cost to not doing it right. And so it's constantly this trade-off that you're kind of weighing. And so I just kind of felt like now was the time that we wanted to go through and do that. But again, I just wanted to make sure that everyone knew it's totally fine that we did it that way. It's the way I recommend doing it. We don't want to always be in a situation where we're paralyzed by worrying about whether we're doing something correctly or not. You need to be able to make that forward momentum, make that always work out fine as you sort of iterate on things. But then the important thing and the thing that separates a code base from one that will work and extend over time from one that's just going to collapse on its own weight is whether you take that time like we're doing now to go through and say, all right, we've got enough down here. I think we know what we want. Now would be a good time to solidify that so that we don't keep accreting problems, right? So that looks pretty good to me. I think we're in good shape there because now we've sort of gotten this straightened out. Now there may be a couple things lurking in there somewhere that we haven't gotten to, but at least we've got a pretty good handle on these all working properly. All bitmaps, including the render target, are assumed to be bottom up, is also true, right? But we've got this situation where we got, unless otherwise said, so we haven't really taken any look at either of these two. And those are obviously going to be a bunch of work that we want to do. And so, yeah, so that's something that we want to take a look at pretty soon here. That'll probably be tomorrow's job. Since we're getting to the end of the stream, I think it's probably a good time to go ahead and go to the Q&A. I can't think of anything else that I want to do. Let me just think if there's anything else that I wanted to do before that's just a 5-minute thing. I don't think so, because I think we want to start looking at Z tomorrow. But yeah, yeah, I think we're all good. So I'm gonna call it there, and I'm gonna go to the Q&A. So if you could, please go ahead and post questions with Q colon before them so I can see them, and try to keep them to stuff that we've done on the stream here, so that these are on-topic questions. If you want to talk about off-topic stuff, come back 15 minutes before the stream starts someday, like 4:45, and that's when I answer off-topic questions and stuff like that. Alrighty. Any questions? 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 Anyone? Has this... Wait a minute. Alright, this is not good. What is happening here? My little question prompter is not getting questions. I wonder if my hex chat is doing something weird. Well, I can read them here. Has this work fixed the normal map issue, or will we need to address that specifically? Well, I'm trying to remember if we had any flips in there, but we can certainly check. We kind of need to go through that with a fine-tooth comb for totally separate reasons as well. But what I can do is I can go ahead and turn this back on, and we can take a look at what it looks like at the moment. So yes, it has, is the answer. At least it has fixed which one of the bitmaps was at the top or the bottom, because that was just the case of that routine wanted to interpret it in this direction, right? Do you think that making the Y component to be bottom will also help make sense of game mechanics like gravity? Not really, because we didn't really have any problems with that before. Most of the problems that we have with any kind of game mechanic stuff is just the fact that we don't have real geometry, so we have to fake it a lot of times in a 2D game, and that's a lot of complexity there for stuff like gravity. But there is one thing that's nice about having Y always be up, is that it always looks like math, right? You know, when you think about like sine and cosine in a circle and clockwise and counterclockwise rotations, those are all correct now, whereas before they wouldn't quite have been, right? Will we be implementing a matrix affine transform in order to handle changes to coordinate systems? We did. So that's what this is. I don't know if you remember. Basically, this right here. Nope, sorry, not that. Where is it? This. This is an affine transform. So, I mean, I guess this might be a time to sort of just briefly mention on the stream, because we'll probably at some point, if we actually want to talk about matrices more specifically, we could talk about it. But origin, x-axis, y-axis. So what I would invite you to think about, remember we've talked about this on the stream a bunch of times, matrix multiplication stuff, right? So let's say I have an incoming vector, and it's got px, py, and let's say 1. It's three dimensions. X, Y, 1, right? This part here is where you get the homogeneous coordinate system part. So if you're talking about multiplying an incoming vector by a matrix, right? Well, we've already seen what happens here. You remember this equation I've harped on many, many times, which is that our new point is always equal to the px times the x-axis, right? So I guess I'll just write giant X for that. Py times the y-axis, and then of course plus the origin, right? Whatever the origin is, right? We could call that p origin or something. We've done this so many times, right? We've done this and done this and done this and done this. Well, what's this equation? Pxx, pyy, p0, right? Well, you know from matrix, the way we talked about matrix multiplication, right? The way that it works is you take like this, and you know this position in the matrix, and you multiply it by this. You add them together with this multiplied by this. you take this multiplied by this, right? So it's px times this, py times that, 1 times this, right? And what you see if you do that, remember we did the column picture before of the matrix here, the px component multiplies the things that are in this first column. Px keeps multiplying that, right? It's px times this for this row, it's px times that for this row, and it's 1 times this for this row, right? So what you end up with is you end up with this right here being the things that are multiplied by px, right? And this here are the things that are multiplied by py, and these are the things that are multiplied by 1, right? And if you put that together, what you get is whatever is in here, we can just, if we call that A, whatever this row is. In fact, I can just do it for you. AX, AY, AZ. I guess we might call this AW. BX, BY, BW, and CX, CY, CW, like so. If this is our matrix, then what you immediately see, right, by doing this thing, if we were going to do the summing, right, because you remember how it goes, it looks like this. It's PX, AX plus PY, BY plus 1, right? CX, that's on the top. PX, AY plus PY, BY plus CY, and finally just 1 for down here. So you'd get AW plus BW. Oh, whoops, no, I didn't do that quite right. Sorry. PXAW, PXAW, PY, BW, CW, right? So if you take a look at how this works, right? I mean, all I did was the matrix multiplication, like I said many times in the stream, right? It's just a dot product. It's just this, 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 right? You start here, and you work in, and you multiply and add, multiply, add, multiply, add, right? And then you go down to the next row, you do the exact same thing. What hopefully you can see here is that px is the common term for here, py is the common term from here, and the 1, right, is the common term from here. So this basically just equals px times a, whatever the a vector, right? If this is the a vector, ax, ay, aw, right? It's px times a plus py times b plus c, right? That's what this is. That's what this matrix multiplication computes. And hey, guess what? That's this equation, right? They are exactly the same. Take a look at that. In fact, you can look at them both at the same time if you want to, right? Same exact equation. P prime equals pxa, in this case pxx, pyb, pyy, plus c, p0. So what that tells you is if you wanted to use matrix math to do the things that we were doing, literally all you're doing is filling out your matrix exactly like this. The x-axis x-coordinate goes here, the x-axis y-coordinate goes here, nothing goes there, right? Because we don't actually want any additional value. We don't want pxaw. We don't have anything for that, right? We've got the y-axis is x here, the y-axis y goes there, and nothing here. And then for the cx, cy, cw, that's the origin. So the origin x, origin y, right? And typically people put a 1 here, but it doesn't actually matter what you put here for our purposes because we don't care what actually comes out. But if you started doing matrix concatenation, you would care. And that's something we probably won't cover today because we'll talk about that if we actually start doing matrix stuff. But this is the homogeneous matrix that you often hear about. This is, for affine transforms, right? And for those of you who care, the upper part here, that's the linear part, and this part here really is what the affine part is. The reason I say that is because oftentimes, and again, this is sort of CG lingo to some degree, because I'm not sure a mathematician would really be all that okay with how it's done in CG. But in CG terms, the way that it's usually said is, if you take that equation that we had, p prime equals px x-axis, py y-axis plus the origin, right? Or I guess we'll just say O. If you take that and you classify sort of how it behaves, well, you remember I drew the diagram. I said, okay, if this is the y-axis, this is the x-axis, this is the origin, right? Then the pxx plus pyy is the thing that scales and rotates our points into their correct position, but it doesn't displace them. So, if the origin of the world's coordinate system and the origin of the transform coordinate system coincided, it would be at the right place. But if the world's coordinate system is actually out here, right, you need to add that origin in. That's why we add that origin in, is to displace the new coordinate frame to the place where it actually is in the world, in addition to rotating and scaling. So typically what we talk about is the rotation and scaling part is the linear part, and oops, didn't make that quite big enough. That's the linear part, and the affine, what makes it affine is the fact that we add in the origin, right? So the fact that we have a displacement in addition to a rotation and scaling is the affine part, right? And another way to think about that is the 0 coordinate doesn't move in a linear transform. There's no amount of rotation and scaling you can do that would make the point 0, 0 go anywhere. Why? Because the point is 0, 0, which means that the x-axis and the y-axis literally drop out of the equation. So if you just had p prime equals px, x plus py, y, you would literally not be able to do anything with the 0 point. And so, because it's the center, it's the transform center, right? It's where the transform occurs around. It's where the scaling occurs around. It's the center of scaling, center of rotation. So nothing will change it. But that's where the affine comes in. The affine part allows you to displace everything by a certain amount, right? And so that's how it becomes affine eventually. Okay, so hopefully, does that answer your question? I don't even know. My little question grabber thing is not working. We have to figure out why. I don't actually know. So I can't actually see what's been going on here, but let's take a look. The mods had to do a lot of work today, just so you know. Uh-oh, what happened? Were we on the Twitch front page or something? I'm sorry, mods. It had been so good for a while, we hadn't had people spamming and trolling, but I guess sometimes it happens. I'm sorry that you had to deal with that, and we all appreciate your work very much, as always. I'm sorry that you had to do that. Stegosaurus. Casey, maybe I missed it, but when will the Z-ordering be done to visually correct sprites in front and behind the character? As soon as we get our Z slicing stuff figured out, we can add a sort for that. But right now it's a little too early because we're not exactly sure what exactly we're going to be sorting on. So you got to give it a little bit longer. It's not quite yet time to call the ball on that. Let's see. Q, it's more correct to call that the translation part. The entire upper part is affine. So pseudonym 73, again, is the resident math person. So much like I said, math people might be uncomfortable with it. I suspect that they are. So maybe I guess what we could say is let's just use what would be an unambiguous term for this so that math people won't have to be nervous about it. Because, they invented this stuff. So one way you could think about it is this right here is like rotation and scaling, right? It's also shearing, but we don't actually allow that really. This right here is translation, right? Or you could think of it as displacement, or you could think of it as the origin, but it's not really the origin, probably the wrong way. It's the displacement because origin means things that maybe are subjective. So it's really the part that's going to translate. So this rotates and scales, this translates. This part right here is there just to make the matrix math, again, work out. It literally doesn't really need to be stored. So when you implement this, you can often just implement it like this, which is exactly what I've done here. You notice I just stored the 3 vectors instead of doing this, because this part will always look like this right up until the part where you start doing projective things, because there's a thing you can do where you start introducing projection via the homogeneous coordinate, which is this extra part that we added here and stuff like that. We have no need for any of that stuff at all. And so really for our purposes, we can really think of the matrix as pretty much just being this part. But because the only reason I went down this little math hole here was because someone was asking about it. I just kind of wanted to point out what those things are so that you start to have a little bit of awareness of it. But I wouldn't really try to super understand it just yet because we haven't really talked about it much and we haven't really seen any reason why we would need to do these things. And so, you typically want to wait to understand something until you actually have a real good reason to, if you can, because then it's sort of a little more motivating, it sticks a little bit better. And so I just wanted to give you this because someone asked about it. I just want to give them a little bit of flavor, but it's not really the right time to dive into a lot of this stuff. When you exit the program, Visual Studio says there are about 8 threads terminated. Is there more than one thread in Handmade Hero right now? Yes, there are many threads in Handmade Hero right now, unfortunately. And the reason for that is that the operating system creates a bunch of threads without our permission, basically. So let me see if I can, in fact, I'll just go ahead and break into the debugger here. What you can do is you take a look at the threads here, this threads window. And what you can see is this is the thread that we actually wrote. This is our code. And here are all the threads that Windows is running. So you can see like Direct Sound has 3 threads. Direct Sound requires 3 threads. So just the fact that we started playing sound was there, right? You've got one that's sitting inside the API. You've got a bunch in NTDLL, which are presumably kernel threads doing something. I don't know. That's a terrifying name right there. Oh my God. I don't even want to know what that means. Why is that in NTDLL? Oh, how the mighty have fallen. All right, anyway, doesn't matter. Point being, these are all threads that are running. We didn't write any of them. We didn't even ask for any of them, but they're just a consequence of using Windows services because a lot of Windows services are implemented with threads in your process space. Now, eventually, we will thread Handmade Hero, and we will have more threads that we wrote, but at the moment, we didn't intend to do that. We didn't write threads ourselves and do any threading. That was Windows creating threads for its services that it just sort of forces us to have, and there's really nothing we can do about that. Kuber Caleb, would it be possible to have the renderer set up so the world curves back as you move along the y-axis? Yes, that is, but that's kind of doing 3D rendering at that point. So the reason I guess what I would say is the reason I don't want to do that is because I don't really want it to look like that, the game. So I apologize for not showing how to do it, but it's really, there's very little extra to do, but it involves having to do perspective correction on your textures if you really want it to be correct. You don't really have to do it, probably. I mean, you could get away without doing the perspective correction, and then literally we've written everything that you need, actually, for it. Because all you would need to do, again, is use the texture mapper that we already wrote, right? Right now, we're texture mapping things this way, and what you would need to do is start texture mapping them this way, right? Like we have it so that you have something that points like this, and it's assumed that this is always going to be scaled outwards like that. What you would need to do is a thing that allows you to produce smaller rows this way. And so typically the way 3D renderers actually work is they rarely operate on quads. They usually operate on triangles. And so, in OpenGL or something like that, you're talking about something that looks like this. But you could write one we could still write one that was doing the quad mapper that way. But anyway, that's really all you would be doing. There's just a couple of annoying things that you have to end up doing to make things work properly if you want to do it that way. And so I'm not going to cover how you do that, but it's not, it could be an exercise for the reader. And especially if you go read Fabian's post. If you remember, I talked about the rigorous blog post that there's like 12 articles on there or more that are like, in fact, it's more than 12, I think, that are like graphics pipeline articles. He talks about, I think he probably talks about perspective correction in there, divide by W and stuff like that. Did I get all the questions? I think I got all the questions. Any other questions? Since I can't guarantee that I got everything, since my little question screener seems to not be able to find the hex chat dump. I wonder if my hex chat is busted. Anyone? All right, looking like we can probably go ahead and end. All right, folks. I don't see any other Q colons on there. So I am going to go ahead and end. Save the mischief board. Hopefully I'm not closing it this time. Hopefully it was just me closing it before and it's not like crashing out or something. So let's go ahead and close all this up. And thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. I'm glad that we're doing a bunch of cleanup. It always feels good to get crufty stuff out of the code. And yeah, I mean, I feel like the render is going really well. I've been happy with how things are going. I think it's going to be a lot of fun to do optimization work on it too, so I'm kind of looking forward to that. So here's hoping that our near field light sampling won't turn into too much of a rat hole, since I really just don't know how we're going to do it. But so we'll continue on. We'll probably need a couple more days just to go through and finish up cleaning out all of the coordinate system stuff and just making sure that that stuff works the way that we want it to. But hopefully we're in the home stretch here, maybe a week or two more of doing sort of the lighting and the cleanup before we can get into the optimization stuff, which I think is going to be fun. And it looks like it's pretty fast too, even without having been optimized at all yet. I'm thinking that maybe that means we'll be able to run the game in software rendering for a good portion of the development, which is kind of awesome as well. So anyway, thank you for joining me. I hope you'll come back tomorrow, 5 p.m., same time, same place on Twitch. Again, if you want to participate in the pre-stream discussion, we can ask off-topic questions, that sort of stuff. Come about 15 minutes early, about 4:45 p.m. Hope to see you all there. In the meantime, if you do want to follow along with the source code at home, you can pre-order the game on handmadehero.org, and it comes with the full source code already, as well as the assets that you see here on the stream, so you can go ahead and play around with it and learn from the series. It's a good way to do that. We also have a Patreon. If you want to support the video series, you can subscribe to that. We always appreciate it. There's a forum site where you can ask questions, and it's also got community ports to Mac and Linux on there, as well as an annotated episode guide. So if you want to catch up with sort of the early episodes, if you're new to the series and kind of want to start from the beginning, that's a great place to do that as well. Finally, if you're trying to watch the series live and you want to know when it's going to air, there's a tweet bot, which is pretty helpful. Basically what the tweet bot does is it tweets out the schedule on the weekend, and it tweets out when the show is starting every day. In the morning it says what time it'll be, and then an hour before it tells you that it's going live. So that's a great way to do it too. All that stuff is good, so check it out. And yeah, and I will sign off for now, and I will see everyone back here tomorrow, 5 p.m. Take it easy, everyone.